Okay, how was your break? Mine was short, but we're ready for the 8.4. Uh, it's called the quadratic formula. We're going to introduce it to you. There is, again, a TI program called Atom Quad. If you have interest in finding out more about it, I can email you the link to it. I can even email you a copy of the program. Thing is it's you use your computer, a cable, or another calculator which has it installed. But either way, it's a great program. So what we're going to do tonight in getting us set up is just see how it works. So what is a quadratic formula? That's what we're going to work with, solving it. We're going to see how applying the discriminant really just is, we can do the same thing by looking at the graph, and we'll understand what this discriminant is. Again, a lot of these techniques, this one, these are 300 to 500 years old. I can't remember my history well enough. I just know it was a while ago. Italian mathematician Tartaglia. I love his name. Tartaglia, something. Okay, it's a cool name, isn't it? Anyway, he was the one that sort of stopped. He was kind of a hothead, and I think he found it, but then somebody stole it from him as a story, and then he got in a sword fight. Ended up in prison, dying young and such. But those are the interesting parts of the whole story. Quadratic formula, not so much. Okay, so we're also going to say that we can use intercepts, which we've been doing by graphing. Okay, we're going to graph it and get those intercepts. Okay, so here's a quadratic formula. Now I remember when I first started teaching 20 years ago, I would start with this. And what you do is you do something called completing the square, which is something we skip because the only reason you teach completing the square is so that people can understand how you get from this formula to this formula. You start moving things over, so you subtract the c, so you got this minus ac. You're going to complete a square. You're going to do a bunch of things. It took up like a lot of, back in those days they used chalkboards, and it took up a lot of space. It took up about 20 minutes. I felt pretty good about myself to be able to actually do all of that. And then I'd look at my students and they'd have this blank look on their eyes, and it really didn't help them at all. So what we're going to do is just say, take a bunch of steps and you get this. So what they've done is they've solved for x. And again, it took smart mathematicians, 500 years. It took them, I think it was like 200 or 300 year process to get to this. It was a big deal in its day. But now we got calculators that does it even quicker. Okay, so what this is, though, this is giving us the x-intercept, right? X-intercept, we can get that graphically. Okay, so solve this equation. I'm going to do it first with the graphing method. Okay, let me, didn't look close enough to figure out 4x squared plus 3x minus 8. Let's go back down to here. We can put it in this way first. So we'll go with 4x squared plus 3x minus 8. We see that it crosses in two places. We click and we got it, minus 1.838 and 1.088. Okay, so we've got our two answers right there. We could write them in here. Point was at 0, so we'll just go 1.1. We'll round that up. And then we're going to watch them go through the solution process. Okay, so they figure out what A, B, and C are. There's A, B, and C. Okay, because they're in those places. They use this formula, so B goes here and here. A goes there and there. C goes here. So they plug in all the numbers. It's just kind of tedious stuff. It's stuff you could do, but then you've got to follow order of operations. So you multiply, you square, then you subtract, then you can take a square root. So they just kind of go through that. That inside there's 137. Now you can add and subtract the square root of 137, which is not a perfect square. It's a decimal value. And again, order of operations says we have to do the top part first and then divide by 8. So we get a plus and we get a minus. Again, that's coming because of the square root. This side is 1.1. That's what we got there. And this one's negative 1.8. And more specifically, negative 1.83. Okay, so you can go through all of this. You'll get to this level. But again, we did it graphically. We get exactly the same answers. Actually, a little bit more accurate than what they came up with. And we see exactly what we're getting. We are reminded we are getting x-intercepts. Over here, we would frequently forget that these are x-intercepts because we don't see the graph. And the only connection that this is an x-intercept is an abstract one that it's equal to 0. Okay, so I remember doing this again and again, and I, it never stuck with me that I'm getting the x-intercept until I started doing it all graphically and said, hey, those are just x-intercepts. That's all there is to this. Okay. And so then they do this and they show there's your graphical solution. I say flip it, do the graphical solution first, move on, let's get on with our lives. Again, here we're going to go ahead, strictly go to the graphical solution first. So we've got 3x squared minus 6x plus 3. Okay, I see there's one solution, x equals 1. And how do I know? Because that's where it touches the x-axis. This is saying y equals 0, that's the x-axis, x equals 1. Okay, so that one I could probably remember long enough, x equals 1. So again, they've got their a, b, and c, that's where those numbers are coming from. They're going to plug it into the quadratic formula. And you can walk through this. Again, the PowerPoints are also in the Canvas, so you can pull them up and walk through them at your own pace if you like. This gives us a square root of 0, right? This is 36, this is 36, 36 minus 36 is 0. We're also going to see this is called the discriminant, but I've got some slides to show that. So x equals 1. We got it. Okay, we did it faster. And seeing the graph, we also know some other things about this. This parabola, we also know this is a minimum value, that y equals 0, when x is 1, y equals 0, that's also a minimum. We would not have known that here. Not necessarily. We would have known it's either a minimum or maximum because that's the only way you can get one solution, but we wouldn't have known whether it was necessarily minimum or maximum unless we look up here and say, oh, that was positive. But again, the graphing way, you will see directly what you're getting. And then I believe you'll be able to make the connections much more clearly than by doing it the old ways. By trying to solve it first and then graph it. Let's do it backwards. Let's graph it first, and then if you want to, you can go through this process, but it's not required. All I want you to do is be able to put in the answer of what the x-intercept is. And there's a method to my madness, so it'll all work. Again, we're going to A, B, and C is how they're going to do it. Since this is positive, that's plus 5, I'm going to say this one probably, when I graph it, it probably doesn't cross the x-axis. That's at least what I'm anticipating. And I had a student ask me, how do you know these things? Are you just like an incredible mathematician? I says, no, I'm not a mathematician, but I am a math teacher who has been paid to teach for 20 years plus. So I've done this a lot, and you start to see the patterns. And so the best way to learn math is to become a math teacher. Get paid for doing it, you'll have more fun with it. Okay, and this is what I mean. I can see it does not cross the x-axis, right? So I could kind of see that it wasn't going because this is plus 5. I knew it moved up. The thing we did on translations, moving up, that sort of helps. I could see, in the y-intercept is 0, 5. It didn't move it all the way up 5, but this vertex was not low enough. There is no solutions here. So, we could just write that. no solution. And we're going to see what they come up with. They're going to plug these numbers in, okay? And what they're going to get here is they're going to get 16. Here they're going to get 20. They're going to get minus 40, right? Which gives them minus 24 as their answer. And you can't take a square root of a negative number. You get an imaginary number, but it's not a real number, so there are no x-intercepts. Okay, we see it right there. This is what we saw. So we were quicker on the draw, and we've got it, and we understand it probably better. We know that it doesn't cross the x-axis. Okay, here we get this, and we're wondering, did we make an error or something? Graph it, you'll see the answers right away. Okay, now this is the other thing, is this is 500-year-old technology, something called the discriminant. The discriminant is the thing inside the square root. Okay, right? This was, if you look at the formula, this is the part inside the square root. What they do is they don't worry about the square root. They just calculate this inside part. And notice if it's greater than 0, that means it's positive. Means we can take its square root and we'll get a plus or minus. If it's equal to 0, if the thing inside, remember, then you get plus or minus 0, which is the same thing. So this is equals 0. One solution, 2 up there. And then if it's negative, we get a negative inside here. So square root of a negative number is not a real number. We know there are no real solutions. But again, what I'm going to say is instead of doing this discriminant part, let's just go ahead and graph this. And then you'll see if you've got 2 solutions, it'll cross in 2 places. If you've got 1 solution, it'll cross in 1 place. And if you have no solutions, it won't cross. You just graph it, look, and know. Okay, so we're going to do this one. Again, what we want to graph, though, is we want to subtract the 3 from both sides. So what we're going to graph is negative 2x squared plus 5x minus 3 equals 0. And again, we just graph this, and then we're looking, are there any x-intercepts? Because they just say use the discriminant. So we said, I'm not going to listen to you. I got a better way. Figure out the number of solutions. Our answer, if it does cross, it's not, those are not our answers. Our answers is how many times does it cross? 1 or 2, or does it not cross? So we're just going to graph it. And again, I think this one might not have a solution. And again, I'm not as confident on this one. So we go with minus 2x squared plus 5x minus 3. Oh, I was wrong. It happens. Even though you get paid for doing math all these times, doesn't mean you know everything, right? That's for true. Actually, I can see let's zoom in a little bit. It actually crosses 2 times, and I could click here and I get at 1 and at 1.5. Cool. Because they do say, again, I didn't read far enough. If it does have solutions, then go ahead and use the formula to solve it. We already know now it has 2 solutions, and those solutions are x equals 1 and x equals 1.5. Just like that, we're done. Now, some teachers want you to show their work. So how do we show our work with this thing? What I say is show a sketch of the graph, and then we could label it. You know, this is how I did it. I graph it, and I got something that goes like this, and this is x equals 1. This is x equals 1.5. I think that's good enough. Okay, so here we're going to do, okay, again, this is A, B, and C. And what they're going to first do is just the part that's called the discriminant. They're going to get a positive answer because that means there's 2 solutions. So they get this is going to be 25, and this is going to be minus 24. So that's equal to 1. Square root of 1 is 1. Okay, so now they don't have to recalculate the square root part. They already know that the discriminant's 1, so they just plug that in. They do have to plug in b there and there. So then you get negative 4 over 4, which is 1, and you get negative 6 over 4, which is 1.5. Two solutions, 1.1 and 1.5. Okay, so we got it graphically perfectly fine. Now here's a special case, and I'll just do this because we did want you to know a little bit about solutions to complex numbers, imaginary. So if we have this, and k is a positive, that's what this is saying. K is a positive number, so like x squared plus 5, 0. Now notice if we use this method where we solve for x by the square root method, we would subtract 5 from both sides, right? So you get x squared equals negative 5, and then we're going to take the square root of both sides. But we did talk a little bit about this, that this negative inside a square root, we can just write that as I times the square root of 5. And again, we get a plus or minus answer whenever we take a square root. There's not going to be a graphical way we could do this because these don't cross the x-axis. These are not real values, so this is what, when it doesn't cross the x-axis, what you're getting is you're getting imaginary answers. Okay, so notice this one, we'll take 17, move it over here. If we were to graph it, it would not cross the x-axis. Okay, but the solutions bring it over. It's negative 17, right? Minus 17, x squared equals minus 17. Take the square root of both sides. The minus comes out as I, so you get plus or minus square root of 17. Okay, so you get a positive or a negative answer. So we could write it both ways with the plus or minus. If we don't have access to a plus or minus, we write it twice, one positive, one negative. Okay. That's as far as we're going to take that, just to know that there are these imaginary answers. And again, where do imaginary numbers and such, where are they helpful? Primarily in electrical engineering. So if any of you are thinking of electrical engineering, again, it's a high-level type of specialized electrical engineering and making like circuit boards that are very, very miniature. At least that's what I hear. I've never done it myself. I just hear about it, that's where that is where these sorts of things are used. Okay, so we've gone through 8.3, 8.4. The homework is ready for you to interact with and get going on. Wednesday or Thursday, depending upon which class you're in, I will be posting the videos for the last two sections, which we're going to get into some exponential functions and graphs, I believe, the last two sections that we're going to look at. And then you're going to be well prepared for college algebra, for those of you going into college algebra. Those of you going into college math, 141 or 142, you're going to be just fine already. It's not as technical math, but the college algebra, you're going to be doing more technical math. And all of these sections are setting you so that you're ready to learn that material when it comes up. Okay, so do well. Let me know if you have any questions, and we'll be in touch.